So diagonal in the downward direction from left to right, 6 times 8 is 48, or 8 times 6. Minus diagonal going in the upward direction from left to right, 7 times 4 is 28. All right, swap the elements of the downward facing diagonal. Negate the elements of the upward facing diagonal. Then carry out the scalar multiplication. All right, so this is 1/20th. So 6/20ths, 3/10, negative 7/20ths, negative 4/20ths would be negative 1/5, negative, I'm sorry, 8, just positive 8/20ths, 4/10, 2/5. And so that would be your inverse. All right, so we get from this a pretty significant condition. I think it's probably mentioned on the previous page. If it's not, then, well, it was going to get mentioned at some point anyway. AD minus BC, which we're going to call sooner rather than later the determinant, that can't be equal to 0. If that's equal to 0, then your matrix will not have an inverse. It's not invertible. They call that a singular matrix. Couldn't even read my own handwriting there. Let me just clean that up. That doesn't look much better. All right, so calculator approach. For 2 by 2, probably more trouble than it's worth. A lot of things are true when it's a 2 by 2. Just easier to do by hand. But just to show you the technique for larger matrices. So go into the matrix menu, go to math. Very first option is determinant. Select the matrix you want it to find the determinant of. And there we are. All right, so that'll give you that. And that's assuming you want to do some kind of, I don't know, combination of the two approaches, because we already know like the inverse approach is pretty easy. But this is how you get the AD minus BC for a 2 by 2 matrix. So now for my inverse, it would just be a matter of, just following the model. We'd have 1 over 1/2, so 2. Swap the diagonals in the downward direction. So 2 goes there, 1/2 goes there. Negate the ones going in the upward direction. And then multiply. All right, so, but again, like I said, that requires you to have known already that AD minus BC is the definition, a numerical definition of a determinant for a 2 by 2 matrix. All right. Number 4 is asking the question in a slightly different way. They're telling us that the matrix A has a determinant of -2, but then they tell you what the inverse is. All right, so another way to express the inverse would be to say 1 over -2 and then manipulate the matrix. Diagonal downs get swapped, diagonal ups get negated. Carry out the operation. That itself should be equal to 5 over 2 for -1 over 2, -1. And so just based on visual inspection, you should be able to get it. You know, you say, what do I have to put in for an H in order to get a -5? I'm sorry, +5. I have to plug in a -5. So I know that the H value has to be a -5. So I can just kind of itemize it here. F has to be an 8 in order to get you a 4. G has to be a -1. And E has to be a +2. So then using the format in matrix A, I could just put those numbers in. So 2, 8, -1, I just lost my place there, -5. I mean, you can set up equations too and solve it if you want, but, you know, set each corresponding part equivalent to one. I don't think it's necessary. Well, at least not for this one. A word problem at the bottom there. A charity fundraiser. We have single tickets and 5-ticket books. We need appropriate matrix equations and the price of a single ticket and the price of a book. So we know what our independent variables are will be the price of each individual item. So we can define our variables. We can call it S and B if we want. X and Y, X1, X2. It's in context, so you might choose something that's a little more relatable. So 12 multiplied by the price of the single book plus, single ticket. 4 multiplied by the price of a single book equals 70. And then 8 multiplied by the price of a single ticket plus 3 times the price of a book equals 50. All right, so again, the idea is to use the use a matrix equation to get this done. So we're looking at 12, 4, 8, 3. Y capital. No good reason for that. All right, so SB, vector SB, would be the product of the inverse of 12, 4, 8, 3 and 70, 50. Now we do have a shortcut for the inverse, so unless the question tells you to use the row reduction technique to find the inverse, you don't actually have to do that. So I just need to find the determinant. So we're looking at 36 minus 32, so 4. So 1/4 on the outside. Swap the diagonals in the downward direction, negate the diagonals in the upward direction. Multiply your scalar. And then carry out the multiplication. So you might have some decimals in there. If that's the case, that's okay. But you could also do it if you want to do it as the vector matrix multiplication. You can do it that, which was from the last unit. But either way, it's going to be fine. So we have a 2 by 2 multiplied by a 2 by 1. So our answer should be in the form of a 2 by 1, which makes sense because our variables are organized in a 2 by 1 fashion. So 3/4 times 70 plus -1 times 50, and then -2 times 70 plus 3 times 50. All right, so 3/4 of 70, 52 and a half, so $2.50, I think. And then 10. Let me just double check that. So 210 cut in half is 105. Cut in half again is 52 and a half, right? And subtract from that 50 is 2.5. You guys are awesome. All right. And then negative 140 plus 150 is 10. So single ticket. Book of tickets.